higher order derivatives is not going to be a very difficult thing, but understanding what they actually mean and represent is the important piece. So let's start out with the first derivative. When we write the derivative, we can write it with the prime notation. We have one little mark there, or we can write dy dx, and that's called your first derivative. Your second derivative, however, sometimes we're interested in finding the slope of the first derivative, slope or gradient of the first derivative, and that's known as your second derivative. Now we write that with two little prime symbols, or we can write it as d squared y of dx squared. The reason the squared show up where they are is explained over here. The second derivative is actually taking the derivative of the derivative, and if we multiply across the top and multiply across the bottom like you're supposed to do with fractions, you can see where that squared comes from. Okay, then we have the third derivative with respect to x. It can be written with three prime symbols or with the cubed notation on the d and on the cubed. Now the prime notation gets a little hairy at this point, so from that point on we really don't write the prime symbols anymore. If we were taking the fourth derivative, we would write it this way. Okay, that would be the fourth derivative. This would be the fifth derivative. We pretty much won't go past the third derivative for the most part. When we start talking about real world situations and problems, the first, second, and third derivatives are the most important ones for us to look at. So let's go ahead and look at a couple problems where we're taking more than one derivative. I'm going to do A, B, C, and D individually, and in between each one I'm going to clear the screen and start the next one. So if you ever want to pause to finish writing something down, feel free. So let's start with letter A. Okay, letter A says find the first three derivatives of f of x equals x to the fourth plus 3x squared plus x. Now, this is pretty simple. We're just talking about the power rule here. So we start to enjoy this, right? So the first derivative is going to equal 4x to the third plus 6x plus 1. Then we want to look at the second derivative. Well, the second derivative is just the derivative of the one before it. So it's almost kind of like a recursive formula. We have to go to the previous one and take the derivative of that. So this becomes 12x squared plus 6. And then when we're looking for the third derivative, we're getting 24x. Okay, so that's the first three derivatives of a quartic. Quartic, first derivative is cubic, its second derivative is quadratic, its third derivative is linear. All right, so now on to letter B, because of course we can't just leave it as simple power rule each time, right? So letter B, it's asking us to find the second derivative, and it gave us the first derivative. Well, that's no big deal. We're doing one step, right? So that just means we're taking the derivative of what's given. So if the first derivative is equal to, and remember we're going to rewrite this with an exponent, so we have x squared plus 4 to the 1/2. Okay, and we're trying to find the second derivative, then I'm going to apply the chain rule here. Okay, so u is equal to v to the 1/2, which tells me the derivative of u is equal to 1/2 v to the negative 1/2, and that's if v is equal to x squared plus 4, and the derivative of v is equal to 2x. So that means then my second derivative is going to equal the derivative of u, so 1/2 v to the negative 1/2 times the derivative of v, which is 2x. And so I'm just going to work on some simplifying. I'm going to go ahead and bring this down to the denominator and use the square root symbol. So it's 1/2 times the square root of x squared plus 4, and that's being multiplied by 2x. And you can see this 2 and this 2 will cancel out. So we're looking at x over the square root of x squared plus 4. Okay, so that is the second derivative. First derivative is the square root, second derivative is x over the square root. Okay? All right, so I'm going to erase this screen and work on letter C. All right, so letter C, what's given is y. So y equals 4e to the 2x. And what it's asking us to find is a derivative, and it's asking us to find the third derivative. And it's telling us where x equals 1. So that's going to come in at the end. But let's find the third derivative. In order to find the third derivative, I have to find the first two derivatives. So I see this being raised to another function. This is telling me to use the chain rule. Okay, so u is equal to e to the v, right? So u is equal to e to the v we'll put the 4 in there so we don't lose it. V is equal to 2x. The derivative of u is equal to 4 e to the v, where the derivative of v is equal to 2. So what we're going to be doing is we're going to be taking, to get the first derivative, we're going to take 4e to the v and multiply by 2. I'm going to substitute back in that v, so that's 4e to the 2x times 2, which gets me 8e to the 2x. The reason I was hesitating throughout there is I really normally don't go through this process when I'm talking about e to a function like this. I kind of take a shortcut, and I'll show you that with the next two derivatives. So the first derivative, what I'm going to see is the 2 is actually comes down and multiplies by the 8, and I get 16e to the 2x. Okay? And then when I go to do, oops, that's the second derivative. And when I go to do the third derivative, the 2 comes down and multiplies by the 16, and I get 32e to the 2x. And I believe in your textbook, never mind. And then, so that's my third derivative, but I haven't answered the question because the question says where x equals 1. So I need to substitute that in. So y, the third derivative at 1, is equal to 32e to the 2 times 1. So that's just 32e squared. Okay? So that's actually the third derivative of that function where x equals 2. All right, now I'm going to work on letter D. So I'm going to clear this writing. And let's look at letter D. We're given the function s is equal to negative 16t squared plus 16t plus 32. And I don't know whether you guys actually recognize this formula or not, but that negative 16 always jumps out at me. This is actually the formula for the path of a projectile, or the height of a projectile, based off of the gravity, velocity, and the initial height. So when we look at the first derivative of that, that's the change in, basically it's going to end up being the I don't want to say speed, let's say velocity. Okay, that's going to end up being the velocity of the object that's being thrown in a projectile path. And then when we go to the next derivative, because it's asking us for the second derivative, that's actually going to be, well, what is the change in velocity? The change in velocity is acceleration. So that's kind of the first piece of where we're heading with why one of the reasons we do derivatives. So let's take the first derivative, and that's going to get us negative 32t plus 16. And then let's take the second derivative, and that's going to get us negative 32. And what that's telling you is that's your acceleration. We'll get to this a little later. That's your acceleration. But that number is actually the value for gravity in feet per meter squared. So the acceleration of an object being thrown in a projectile path is actually gravity, because that's what's changing its speed, basically, is gravity. Okay, I'm hesitant to say speed because speed is slightly different than velocity, because speed, for those of you who have had physics, speed is the absolute value of velocity. So we're actually going to be looking more at velocity in this class. All right, anyway, on my little tangent, right? Okay, so I'm going to go into the next problems in the next video.